It is now my privilege to introduce our keynote speaker. We're pleased to have with us Dr. Bjorn Lomborg. He is a researcher, writer, and academic, and Dr. Lomborg's mission is to identify the most intelligent approaches to create a positive impact and to research the smartest ways to do good. He is a native of Frederiksberg, Denmark. He is president of the think tank Copenhagen Consensus Center, where he works with the world's top economists to find and promote the most effective solutions to the world's greatest challenges, from disease and hunger to climate and education. After his presentation, Dr. Lomborg will take questions from the audience. So please join me in welcoming Dr. Bjorn Lomborg.
Hey, thank you, Todd. Thank you so much. Thank you. It's great to be here, and I would love to talk to you about how we should think about climate change. So what I do is really, I'm very fortunate, I work with a lot of the world's best economists. We work with more than 300 of the world's top economists, 7 Nobel laureates, in trying to figure out what should you do if you want to do the very most good in the world. We find a lot of other issues that we should be focused on: tuberculosis, on malaria, on clean drinking water. We should focus on very simple things like education. But very clearly, for most people in the rich world, and certainly most of your constituents, they will be very, very worried about climate change. So climate change is a big issue, and what I'd like to do is to try to walk you through some of the things that I think is crucial, both for our general understanding of how should we tackle global warming, but also your conversations with all the people that you're going to be meeting, talking about how do we most effectively figure out climate change. So I've shown up here, and really I think it's a question of not having this conversation about is it real or not. It is a real issue, but get a sense of proportion, get a sense of how scared should we be, and the short answer is we should be a little concerned, but not terribly scared, and how should we address this? So is this something we should spend lots of trillions of dollars, as many politicians around the world are now suggesting, or is this something where we should be smarter? And again, of course, I'm going to actually show you some of the smarter ways to think about climate change. So fundamentally, yes, global warming, it's real, it's man-made. I don't think, so again, I'm a social scientist. I work with a lot of economists and other people like that, but I work with a lot of the people who've been part of the UN climate panel reports. I think it's very obvious that the basic point is, yes, this is a real problem, but we also need to get a sense of proportion. It's often vastly exaggerated. So what I'd like to do first is to walk you through some of the things that I think is on many of your constituents' minds, is what we very often hear about in the media, and put it into context so we actually get a sense of proportion. We very often hear this idea that global warming is pretty much the end of the world. So, the Biden administration will talk about this as an existential crisis. I'm just going to look at Guterres, who's the UN Secretary General, so in some sense the representative for all people on the planet. He's also one of the guys who most use excessive language on climate change. You heard him lately call it global boiling, which is just beyond ridiculous. But he says this, and he's a good representative of sort of the general tenor of what people say in the rich world. His quote is, "The world is facing a grave climate emergency. Every week brings new climate-related devastation: floods, droughts, heat waves, wildfires, superstorms." I'd like to walk you through some of those claims. I'm going to talk for about 45, 50 minutes, and then we'll have 25 minutes for Q&A, so please feel free. I'm not going to be able to go through everything, so please be ready with some great questions, and we can talk more about some of these issues and dive more into them in specifics. But I'm going to go through certainly floods and heat waves and wildfires and superstorms, and he also says we're in a battle for our lives. And he would argue climate change is the biggest threat to the global economy. What I'm going to show you is There's a tiny bit of truth in this. So again, climate change is a real challenge. But most of this is vastly exaggerated. And of course, exaggeration is a very bad way to make good policy. It's also a terrible way to inform our youngsters. If you're making people panic, you're very unlikely to make for good policy. So again, let's get a sense of what is the real sense of the issue. There is a problem, not the end of the world. So let's look, for instance, at hurricanes. Hurricanes used to be an enormous conversation, especially in the US, because it's also the place where it creates the most damage around the world, but also in general as an indicator for global warming. What do we actually know? Well, if you look at the UN climate panel, the so-called IPCC, I would argue that they are the gold standard for what we know about climate change. They tell us in the past, it's really hard to identify trends in tropical cyclones, as they call hurricanes. It remains a challenge. They also have low confidence in most reported long-term trends. I'm going to show you the one long-term trend they don't have low confidence in, because it's the American one that we actually have very strong confidence in. In the future, what do we expect with more global warming? We expect that we will see more intense tropical cyclones or hurricanes, and that's bad. We also expect that we will see fewer of these hurricanes, which is good. Unfortunately, having stronger hurricanes is more bad than fewer hurricanes is good. This is one of the reasons why global warming is a real problem. We will have more problems, but we need, again, to get a sense of proportion. So let me just show you the best long-term data that we have in the world, which is landfalling hurricanes in the US. Now, remember, if you just count the number of hurricanes in the world, it's vastly affected by the fact that we've got much better technology. Back in the 1930s, we did not know that there were hurricanes out in the middle of the Atlantic unless a ship happened to pass through. And there were lots of places in the Atlantic that had virtually no ships at any time of the year. Today, of course, we can see this on satellites. This is one of the reasons why you hear there are more and more, for instance, named storms. We know that technology is driving that number up just simply because we get better and better at discovering it. But there's one thing that we do know has remained similar, namely landfalling hurricanes in the US, at least since 1900. It's very unlikely that there's been a landfalling hurricane in the US since 1900, and nobody noticed. So this is why we can actually show you this graph and say, how many landfalling hurricanes have there been in the US since 1900? And the answer turns out to be a slightly declining number of hurricanes, not increasing number of hurricanes. Again, this should make people a little concerned, because a lot of people believe that because of global warming, we're going to see more hurricanes. No. But that's, of course, also what the UN climate panel tells us, that we're not actually going to see more hurricanes, we're going to see fewer hurricanes. But if we look at the strong hurricanes, which is really the question, are we going to see a lot more strong hurricanes? So let's take a look at major hurricanes, category 3 and above. Again, for the US, we've seen a slight decline, not an increase in the numbers. The point here is that there is no way that we can actually look at the data and say, this is terrifying. Yes, there's a problem. We have theoretical reasons to believe that over the coming century, we will probably see more stronger hurricanes, and that's a problem. But again, we need to get a sense of bearing, and it certainly does not support the idea of the UN Secretary General that we're now seeing super storms everywhere. No, what you're seeing is more in the news, but that does not mean that it's actually reality. You need to look at the numbers. So that's also why, if you look at the global hurricane energy, which is perhaps the best measure of the total destructiveness in the planet, we only have that since 1980 because then we have reliable satellite data, it actually does not show an increase. If anything, last year, 2022, was the second lowest ever in the satellite era. Did you hear that? No, because it's not news when things are not bad, but it doesn't mean we shouldn't know. It actually really helps inform us. And again, this is one of the things when your constituents will come up and say, I'm really worried about climate change. What are you doing to fix this? Well, one of the things we should say, did you actually hear that the total hurricane energy last year was the second lowest ever? in the satellite era, there's possibly not as much reason to be worried as you might think there is. Let me just show you another one, and this obviously has huge renewed conversation because of the terrible fires in Hawaii. People will show you wildfire all the time and tell you this is because of global warming. But you need to know, again, what the data shows. We have good data from around 2000 until today because of satellites, and we have reasonably good data from 1900. This is because all the UN climate models actually need to estimate how much fire has there been every year since 1900. So let me just show you how much fire is there on the planet. Is the world burning up? As we're being told, for instance, New York Times last year made a whole section. They had 40 people working on this to tell you, they called it postcards from a world on fire. Is the world on fire? Well, actually, no. It's burning less and less. So if we look at the historical reconstruction, which is the data from the UN Climate Panel, it shows that we've gone from a world where every year about 4.2% of the world burned down to about 3% around the turn of the century. That's a tremendous opportunity. Most of this, of course, is because people adapt. Most people don't like fire, and so we make sure it burns less. But this does tell us the world is not on fire. It's actually burning less and less. Now, of course, the real point here is we have satellites since 1997 or 2001, depending on which satellite data series you're going to use, until today. What does that show? Again, if you look at most of the media coverage, you would imagine it would be going up. It would be getting worse and worse. We're living on a planet on fire. Not so. Satellite data shows, and this is NASA satellites covering the entire planet every 24 hours, finding out all major fires, so everything above, I think it's 30 hectares. So very, very small fires are not counted, but everything else is. In around 2000, a little over 3% of the planet burned each and every year. Last year, 2022, was the lowest ever at 2.2%. Have you heard that anywhere? You'd struggle to find this reported anywhere, yet this is what the data tells us. And again, it's important to say this is not just because we burnt up all the forest. Actually, there's more forest now. Again, this is satellite data. There's more forest now than there's ever been since 1985 when we have good satellite coverage of forest. Again, the point here is the main reason why we're seeing less fire is because people actually adapt. People don't like fire, and so we make sure that there's less fire in the world. We need to understand that when we're told that there's more and more fire out there, it's because there's more and more fire on CNN. But it does not mean that there's more and more fire in the real world. We're badly informed if we think this is actually true. Now, if you look out into the future, what does the climate models tell us? If you include everything, so it's important to say, if you only look at what happens as temperatures rise, you're going to see more fire, which is what you constantly hear. But if you actually include that there's also going to be more CO2, which is what's driving climate, there's also going to be a different set of vegetation because of more moisture and because of higher CO2 fertilization. And of course, there'll also be human endeavors. What you actually see is if we do nothing about climate, it'll still be declining towards the end of the century. If we do strong climate policy, it will decline even more. This does tell us that climate is a real issue. If we do nothing about climate, the world will not burn quite as much less than it does today. But it's not the conversation that most people hear, namely, the world is going to be on fire if we don't do anything. No, it's going to be slightly less more on fire than it will be today. But if we do climate policy, yeah, we can do even a little bit more. But fundamentally, the world is on the right trajectory. We're seeing less and less fire, and the question is, do we want a lot less fire and a little less fire? That's the real question. Of course, this would scare our kids a lot less. Again, we need to have that information. Let me just show you the last bit on floods before I move on to talking about, so what should we think about this and how should we attack it? Floods, again, is one of those things that every time there's a flood, people will say, see, climate change. Well, actually, if you look at what the UN Climate Panel tells us, at the IPCC, they say, in summary, there's low confidence in the human influence and change in high river flows on the global scale. They basically tell, you can't tell right now, and actually, they don't believe that we can find or identify any climate signal out of the natural variation, even by the end of the century, even in a high emissions scenario. So the fundamental point is, when you're being told this is all global warming, it's mostly hokum. Some of it will be, some of the things that didn't happen would also be, but fundamentally we can't see the signal. But we also know this in data. Again, let me show you the cost of US flooding. Unfortunately, this is a little delayed from the US authorities, so we only have to 2021, but we have from 1903. And if you look at the percent cost of GDP for the US, it used to be terrible. In 1913, you had the big flood in the Mississippi. It cost more than 2% of the US GDP. Since then, it's dramatically declined. So we've gone from an average of about 0.5% to an average that is 10 times lower. Again, it's important to make this in percent of GDP. Even the UN argues that's the right way to do it, because obviously if you have twice as much stuff, the same flood will have twice the cost. So you have to compare it to how much stuff is there, and GDP is a good indicator of that. So what we've shown here is that while the UN Secretary General and Biden and everybody else, mostly in the rich world, will be talking about we're facing an unprecedented threat from climate change and we're just seeing worse storms and everything, that's not what the data shows us. If anything, we're a more resilient species and we're actually doing pretty good. Climate change will still be a problem, yes, but it's not this catastrophic end of mankind. And that's important because one is a policy issue that we need to fix. The other one is really a meteor hurtling towards Earth, and we need to do everything we can to fix it. We just got to get everything together, spend everything in the kitchen sink. We got to get back Bruce Willis and set him up there and do something about it. But of course, the real argument here is this is one of the many problems we need to fix, and we're not doing very well if we scare our kids and scare everyone else witless without the right data. So what I want to show is why are we keep getting it this wrong on climate change? I think the main argument is we forget that people are really, really resourceful. We actually do adaptation, and we know how to do this. Let me show you one graph that I think is the strongest argument to show people who are really worried about climate change, namely the number of deaths from climate globally over the last 100 years, so from 1920 to 2022. We have good data from this, from the International Disaster Database, and what I'm going to show you are all the deaths from floods, droughts, storms, and wildfires. So how many people used to be killed by these very clearly climate-related disasters? The answer, turns out, it's very, very varies from year to year, obviously, so I'm averaging this per decade. And in the 1920s, the average death was almost 500,000 people would die each and every year. These are huge catastrophes in China and India and elsewhere that you've never heard of. But they were real. Of course, they actually killed, millions of people. The average is almost 500,000 people. If you ask most people what this graph looks like, most people would, of course, think it goes up. It gets worse and worse. That's what we hear in the media all the time. Now, I've kind of given it away because there's no up in this graph, right? But fundamentally, what we see over the last 100 years is a dramatic decline of 98%. In the 2020s, we've seen less than 10,000 people die each year. This year, Hawaii will be one of those counts. More than 100 people will go in there, along with many other catastrophes from India and China and elsewhere that you probably don't hear about, but should hear about just as much as we should hear about the Hawaii problems. The real point here is to recognize that because humans are incredibly adaptive people, that we know how to deal with many problems, we actually fix most of them, and we fix them pretty well. This is mostly a description. Sorry, I just want to make sure that my graph was still here. This is a great example of what happens when you get out of poverty and when you get richer and when you get more resilient. You deal with problems. This does not show us whether climate is actually making this worse or not, but it shows us that wealth and resilience vastly outweigh anything a climate signal could come up with. This is why the real issue in much of the world is not to talk about, so should we try to cut carbon emissions to make sure that people are slightly not worse off in 100 years? It's about making sure that people are not poor, that they're not unresilient, that they actually get resilience, because that means they can handle most of these problems. We have actually, over the last 100 years, reduced our death from climate-related disasters 98%. Of course, remember, at the same time, the world has quadrupled in population, so actually the individual risk has dropped even more. It's dropped more than 99, so around 99.5%. This is a fantastic achievement. Do you hear this? No. Because we just hear the individual events that make up this tiny bit here at the end. So we'll hear a lot about, I don't know if you remember a couple of years ago, about 300 people died in Germany from a flash flood. Terrible, especially for those 300 people and all their dependents. Of course this is terrible. But you need to add up all of that, and it's very little terrible compared to what it looked like in the past. We are much, much safer. And if you only hear about the things that happen, but don't hear about how they happen much, much less than they used to, you're not being well informed. So let me show you another graph. And this, again, is some of the studies that look at flooding. So what will happen as temperatures rise? We're going to see more sea level rise. This is just simply an obvious consequence of seawater, just like everything else. When you get warmer, it expands. And when you have a couple of miles of sea level, it will actually increase. So we estimate somewhere between 1 and 3 foot of sea level rise. What will happen with future flooding in the world? Well, let's take a look. This is one of the most quoted studies. It's also one of the few studies that have actually looked at what happens if you include an adaptation and what happens if you exclude it. So what they found was in 2000, about 3.4 million people were flooded across the world each and every year. This is model estimates. Again, there's no way you can actually do this in actual numbers, because what does it mean to get flooded? It's a very elastic definition. It's one that changes over time. So this is model estimates. It's an average of, I believe, 5 different models, 6 different climate models, and 3 different economic models. So what they found was 3.4 million people are flooded every year. That has a cost of about $11 billion. There's also a cost to building all the dikes that keep people safe, about $13 billion a year. The total cost, so the 11 plus $13 billion annually, translate into a cost of 0.05% of global GDP. What that means is, first of all, this is not a catastrophic impact. 0.05% of GDP is not a catastrophic impact on the world. It's perhaps a little surprising that it's not bigger, but of course, remember, we're in North Dakota. Sea level rise is not a big issue here, but it is for a large portion of the planet. What will happen if you imagine the worst case warming with the highest population and with the highest GDP? So all the worst things, actually it turns out if you change all of these, you get the same sort of signal, but I'm just going to show you the worst case outcome. So let's assume that we're going to see a 3 feet of sea level rise over this century. What will happen? Well, if you assume that nobody does anything, it will get really, really bad. So this is the graph that they show. With no adaptation, 187 million people are going to get flooded each and every year. This will have a huge cost. They estimate about $55 trillion in annual flood cost. Now, the dike cost, of course, will be very low because we're not doing anything, but the total cost is going to be more than 5% of GDP. This is the standard argument that you hear in the press all the time. The original data for this is actually from a 2011 article, but it keeps being repeated, and it's been in the headlines in New York Times and Washington Post, many other places. 187 million people are going to have to move, or as Rolling Stone said, they're all going to drown. And of course, what we have to recognize is this is not a catastrophe that's happening overnight. It's basically assuming that people are going to be, standing in the waterfront and watching the sea level rise over decades, and now it's at my ankles, and now it's at my knees, and now it's at my hips, and now I can't breathe anymore, and then I die. That's an implausible argument, right? What people will actually do, of course, is move, but more likely, people will buy adaptation. We know how to do this. If you've ever been to Holland, you know Holland is a country where 40% of the land surface is below sea level. Yet they've fixed this really, really well. And it's a very, very low cost. Am I the only one hearing a very annoying sound? Apart from my voice? What is this? We're checking. Okay, all right. I'll just go on. So Holland has actually done this so they made an estimate of how much has it cost to adapt their entire country for the last 60 or 70 years, so since the 1950s. The total cost has been about 10 billion euros or $10 billion, very, very small amount for a rich country over 70 years. This is very cheap to adapt to. And so, of course, people are actually going to adapt. And what happens if you assume that people will adapt? You get a very different outcome. And just notice the blue line, because it's almost impossible to show. The blue line shows that basically you will, if you assume adaptation, see virtually nobody get flooded by the end of the century. The researchers also say this is what is likely to happen, because this is what all rich and even pretty poor countries will, of course, do. It will cost still $38 billion in flood cost, because there'll be much more stuff to flood, and it will also have much higher cost in dike cost, because you actually have to put up all those dikes that everybody has already in Holland. But the total cost will be phenomenally low, because we're going to be much richer. It's going to be 0.008% of GDP. So what actually happens is, when you take into account that we're going to adapt, we're going to see much lower damages. We're going to see many fewer people die, and it's going to cost us a lot less. This is what development means. This is why climate change is a big issue in the news, but it does not actually mean that we're much, much worse off as individuals or as a civilization. We are going to be much better off. Now, if we had done climate policy, instead of 15,000 people being flooded every year, it would only be 10,000 people. So we could make it even better. But remember, the big thing was that we avoided 187 million. We got it down to 15,000. Now, it'd be nicer to get it to 10,000, yes, but we also have to ask ourselves, how much are we willing to pay? Probably not trillions of dollars. And this, of course, is also why, if you look at the global data, we only have good data from 1990, the total cost of all climate damage, so all weather-related damages in the world, we have good estimates from 1990, in percent of GDP has not been going up, as most people would believe, but actually slightly declined. I also have the 2023. It's obviously not done yet. It's based on the first half of the year, and the second half, because that's where the US hurricane season, which is by far the biggest thing, so it's extrapolated from the historical relationship between first half of the year and a full year. But what it shows very clearly is damages from weather are not increasing. If anything, they're slightly decreasing, and that's certainly what the data shows us. This tells us we need to stop having this panic attack about climate change. Yes, there's a real problem. It's not the end of the world. What I want to show you now is, so how do we deal with it currently? I would argue that our current climate policies are both unrealistic and they're also unsustainable. So if you look at the amount of renewable energy that we have in the energy system, people love to say that we're going to go to 100% in a few short decades. I think most people have no sense of what the historical record and certainly what the progress so far has been. If you look at the world since 1800, we started out in 1800 all being renewable. We were pretty much, it was 94% renewable energy in the world, because everyone except Great Britain, or England really, we're just using renewable energy. Since then, we've spent the last 2 centuries getting rid of renewables because fossil fuels gives us much, much more power, much more reliably, and typically much cheaper. What you see here in the last couple, so the main reason why it doesn't go down to 0 is because a lot of poor people still use renewable energy, so that's mostly dung, cardboard, wood, whatever people can get their hands on to cook and keep warm, which gives terrible indoor air pollution. But that's the main part of renewables that have been steadily at around 13, 14% since 1970. What you see here is also the slight uptick. This is all the effort of the whole world bringing together everybody and talking about we need to do something about climate change. Yes, it's gone up from about 14%. Today, we're almost at 16%. It's not very much, and we've spent, remember, trillions to achieve this. If you look at the International Energy Agency, which is the OECD for energy, most realistically assumed to be the best sort of prognosticator for the future, they show if every nation in the world, so the US, EU, Japan, everybody else, does everything they promised with their climate proposals, this is what will happen till 2050. Yes, we will see more renewable energy, but we're not going to be anywhere near what most people would suggest. No, we're going to be at 100%. No, we're not. Not anywhere near. The world is going to be at about 31%. And remember, this will cost literally many, many trillions of dollars. If we do this, yes, we'll be at 31%. If you look at this is not even linear, but if you assume that it's linear, that means that we'll get to 100% by the end of next century. We need to get people to realize that the reality of the world is we're not going to go to net zero anytime soon, which of course is also why actually promising to go to net zero by 2050 or something else is going to be phenomenally costly. There's actually no academic, or at least that I know of, academic estimates, but McKinsey did a study last year that indicated how much is net zero going to cost. They found that the very cheapest and most effective way, if all politicians across the world does all the smart stuff everywhere and only the smart stuff over the next 30 years. This is a pretty big assumption, but if they do, it'll cost us $5.6 trillion each and every year, or about 5.4% of global GDP. That's more than a third of the global tax intake of the entire world. I don't need to remind you that most countries are not just going to sit around and say, sure, we're going to spend a third of our global tax intake on climate policy. This shows you the individual nations and their cost. If you look at Russia is going to cost about 15% of their GDP. Do we honestly believe that Russia is going to say, Putin is going to say, yes, I care so much about climate change, I'm going to spend 15% of Russian GDP on this. But perhaps more realistically, do we really believe that India or Sub-Saharan Africa is going to spend 8 or 9% of their GDP on going net zero? If you look at the US is going to cost more than $1.1 trillion this year, or about 4.6% of US GDP. Again, nobody's actually doing this, but this is what it would cost if we actually lived up to what politicians suggest. $1.1 trillion this year, that's pretty close to one Build Back Better bill, not the one that Biden didn't manage to get through Congress, every year. Let's just think about that. He didn't manage to get it through 1 year in the US Congress, but we're somehow suggesting that we will manage to get this through every Congress for the next 30 years. That's just implausible. That's just not sustainable. And we need to be honest and say this. This is just not going to happen. There is nobody who's going to be willing to pay this amount of money. If you look, there's a new Nature study that showed what would be the cost of US if they actually achieve the Biden's goal of going net zero by 2050. What they found was if you try to reduce, and again, these were models that were published, they've since disavowed the 95% cost, although it was part of the published study, but it does show you what the cost is likely going to be. If we just reduce 20% by 2050, it'll cost each American $75 per year. Most people, if you ask them, show that they're willing to pay about that. They'll pay, say, $100, maybe even $200 to fix climate change. But this is a very, very small part. If you go up to 40%, you'll have to pay almost $500 per American per year in 2050. That's most likely going to lead to most people voting that person out of office who suggests that we should be paying almost $500. You go 60% is going to cost about $2,000. You'll definitely vote out everybody. At 80%, it'll cost more than $5,000 per person per year in the US by 2050, and 95%, the researchers couldn't actually make the model to 100%, will cost more than $11,000 per person per year in the US. Do you know anyone who would say, sure, I'm going to pay that? You know, yes, there's probably a few, but it's certainly not anywhere near a majority of the population. And this, of course, would have to be repeated across the world if we're actually going to achieve that. So how do we think about smart climate policy, and how do we get a better discussion about what we should be doing? Well, I would argue that this is what climate economists have been working on for 30 years. I'm going to share with you the only climate economist in the world who has gotten the Nobel Prize in climate economics, William Nordhaus from Yale University. He spent 30 years on doing this, and I'm going to show you some of his numbers. Most models show very similar results. And what he basically points out, and this is what we need to get everyone to understand, is climate means costly damages. Climate is a real problem. It has costs. We need to recognize that. But we also need to recognize that climate policy has costly damages. Since there's nobody but us to pay for this, we should try to find a way to minimize the sum of those two costs. That's basically what he got the Nobel Prize for, and I'm going to show you how to think about that. So first of all, what's the damage from climate? Well, there's been lots of studies. This is, again, the best overview of all the different studies, so I'm showing you those in different dots here. The bigger circles are more reasonable studies. What you have out here is the temperature increase, so 0 degrees temperature, no climate change. 18 degrees Fahrenheit temperature increase, lots and lots of climate damage. And what you see there is basically the impact in percent of GDP, which is how you typically do this. And what you see is there's, not surprisingly, no impact if there's no warming, and it tends to get negative and greater negative impact. This is what the Nobel Prize winner suggests is probably the best indicator. Again, notice there's great uncertainty. We don't have all the data, but this is what it's realistic we will see. By the end of the century, if we did nothing about climate, we might see about a 7-degree Fahrenheit increase or about a 4% cost in GDP. We will feel like we are, on average, 4% less well off than we otherwise would be in 2100. Remember, by the end of the century, the UN estimate the average person in the world will be about 4.5 times as rich, or 450% as rich as he or she is today. That's an amazing achievement. And this is the standard assumption from the UN. This is one of the reasons why we're going to see a lot of climate change. If people are not richer, they're not going to be emitting a lot more CO2. So we're going to be much richer. But because of global warming, we're not actually going to feel 450% as rich. We're only going to feel 434% as rich, right? The 4% reduction. This is an important way to explain climate change. Yes, it's a real problem. It's a problem that we're only going to be 434% as rich rather than 450%. But no, it's not the end of the world. If you showed this to most kids that are terrified of climate change, I think they first of all believe that you're lying, but they would mostly be like, but that's not terrible. No, that's the point, right? This is a problem. It's not the end of the world. So what does Nordhaus, so the guy who won the only Nobel Prize in climate economics, show us? If we do nothing, we will end up with 7.4 degree Fahrenheit temperature rise, and he estimates the total cost is going to be $140 trillion for the world. That's a huge cost. That's certainly something we'd like to avoid. Now, if you have lower temperatures, so say 6.75 degree Fahrenheit, you will only have about $110 trillion in cost. If you have even lower cost, if you have even lower temperatures, you have even lower cost. I would argue this is what everyone shows you in all the media all the time, that high temperatures, very bad, lower temperatures, not quite as bad. And it's absolutely true if you only look at the cost of climate. But that's not the only cost. You also need to look at the climate cost. Sorry, the climate policy cost. Now, what's the climate policy cost of no policy? It's zero. What's the climate policy cost of trying to get to 6.75 degrees Fahrenheit by the end of the century? Well, William Nordhaus calculated that. The cost is going to be about $20 trillion. Get to 5.3 degree, and again, I'm just showing you a few of these, it'll cost about $100 trillion. Get to 3.9 degree, which is actually higher than what Biden and many others say, but we actually believe that that's probably not possible to get to, but that will cost a phenomenal $350 trillion. We have to pay both of those costs. Nobody in the media tells you this. They tell you that climate is costly, but they forget to tell you that climate policy is also costly. What William Nordhaus got the Nobel Prize for was basically to add these two up. So if you want a Nobel Prize, here's how to do it. So you basically say, here are all the costs from climate. Those are the ones I showed you first. And then you add on the policy costs. So no policy has no policy cost. The 6.75 degree has a little cost of 20 trillion. The second one has much higher cost and much, much higher cost. Since we have to pay both, William Nordhaus points out, what's the best outcome in this? It is actually the 6.75 degrees. It is not the lowest temperature, because the lowest temperature is only good if you only consider climate cost, but forget that there's a climate policy cost as well. But you need to pay both. And if you do it right, what you find is we should do some, but definitely not too much climate policy. We shouldn't do too little either, and right now the world currently is not doing enough, mostly because India, China, and everybody else are not doing enough. In most rich countries, we have sort of a mix of too much and too little, but fundamentally, the point here is to recognize that there's a much smarter way to think about climate policy that we're not dealing with, because we only talk about the climate cost and forget the climate policy cost. If you include both, and that's what you get the Nobel Prize for, we actually realize we should cut some, but not too much. Yet most people just never hear this and don't talk about it. So what should we do? And then I'm going to shut up and I'm going to open this for questions. But really, what are the smart ways to tackle climate? Well, we know, because we have lots and lots of research on this. And I'm happy to say that we've been part of that conversation. We worked with more than 50 of the top climate economists, 3 Nobel laureates, to find out where can you spend money and do a lot of good. Also, where can you spend money and not do very much good when your goal is climate. So let me just show you 4 examples that are very well documented in the literature. What works, and perhaps especially what doesn't work. If you look at the EU 2020 climate policy, which was basically to cut 20% of the EU emissions by 2020, you can sort of hear why this was mostly a policy conversation, because they just used the word 20 a lot. But cut 20% by 2020 using 20% renewables. It turns out that's a terribly ineffective way to help the world. It costs literally hundreds of billions in dollars and would only help the world a tiny bit in 100 years. We estimate that for every dollar spent, the EU, for every dollar the EU spent on climate policy, it would do good for the world in the sense of avoiding future climate problems for the world worth about 3 cents. That's why it says 0.03 up here. I don't think I need to say, but let me just spell it out. Spending $1 to do 3 cents of good is a bad deal. You could just have given away the $1 and done 97 cents more good, right? So don't do that at home. Likewise, if you look at the Paris Agreement, it actually, when you do the calculations, it does do some good because it actually reduces climate impacts in the long-term future, but it also does so at very high cost. We estimate that for every dollar spent, the world will achieve about 11 cents of climate benefits. Again, a bad deal because you could have done 89 cents more good by just giving the dollar away. Why is it better? Well, fundamentally, it's better because better than the EU climate policy because in the Paris Agreement, we also, at least in principle, got the China and India and many others to promise some sorts of cuts. Whether they're actually going to deliver on them is a very different thing, and that's not what we're evaluating. We're simply saying it's more effective to cut carbon in the poor part of the world because they use it much less effectively, and it's also cheaper to cut it there. And so we should cut more in the poorer part of the world and less in the richer part of the world where most of climate policy takes place. But needless to say, both of these are bad deals. These are the kinds of deals that most politicians love to talk about. They love to tell you, this is what we should do. Unfortunately, it's a very ineffective way to help the world a tiny bit at very high cost. But there are two great ways, or reasonably good ways, to deal with climate policy. One, and I'm pretty sure some of you are going to be strongly against this, but I'm going to say it anyway. A smart global carbon tax is a reasonably good policy. So if we actually price carbon at a reasonable price, so we're talking somewhere between $10 and $40 per ton of CO2, and we did this globally, it would actually lead most people to do smarter behavior. This is what an economist will tend to say. If you price stuff, you make people calculate it into their own decision. Am I going to drive somewhere today? Well, not only will it have a cost in terms of, I have to pay for my gas, I have to pay for my time, I have to pay for the depreciation of my car and all these other things, but also that there will be a carbon tax on top of that, which tries to reflect that will lead to long-term damages for the world. If you do this well, and even if you only do it sort of well, it's probably still a reasonably good idea. What we find, this is Nordhaus numbers again, it'll have a huge cost, but it'll have benefits that are about twice as big. So for every dollar spent, you'll actually do about $2 worth of good. The important part is also to recognize this will do very little to actually fix climate change. As I pointed out, if you look at the Nordhaus outcome, what we see is that instead of 7.4 degrees, we'll go down to 6.75 degrees Fahrenheit. That's a little bit of a solution to climate change, but not very much. This is not the predominant way we're going to solve climate change, and that's why our Nobel laureates actually found that there's a much smarter and much more effective way, which is the one that we should be most focused on, namely green energy innovation. We estimate that for every dollar spent, we will do $11 worth of good. It's not rocket science, really. Right now, the reason why most of the world doesn't want to switch is because going green is costly. Now, people will tell you that solar and wind is much cheaper than fossil fuels, but of course, if that was actually true, the whole world would already have switched. The reason why you have to twist everybody's arm at all these summits and nice places where bureaucrats go to have vacation is because it's actually costlier to do so. And that's why most people don't want to do it unless they're forced to do it or have incentives from an Inflation Reduction Act and so on. So the fundamental point here is, as long as green energy is more costly than fossil fuels, you will have a few rich, well-meaning people switch a little bit at high cost and feel very virtuous about themselves, but it'll not have very much of an impact. If we could make green energy cheaper than fossil fuels, everyone will switch. If you think about it, this is how we've solved most problems in the world. Back in the 1850s, long time ago, the world was running out of whales because whales had that wonderful thing in their heads mostly, which was whale oil, which just burnt much, much brighter, much more safely. It didn't soot. This was why whale oil in the 1850s lit up pretty much all of Western Europe and North America. But we almost hunted the whales to extinction at the same time. Now, the standard climate approach dealt with the whales in 1850 would have been to tell everyone, I'm sorry, could you not do that? Don't kill the whales. Instead, go back to that sooty old thing that doesn't burn so bright. Would you please do that? Not surprisingly, most people would not have accepted that. What did solve the problem was that we had innovation. Somebody figured out in Pennsylvania that we have oil in the ground, and it happens to be much, much easier to get kerosene to light your lamp. It's just as clean, and it's much cheaper, and it's much easier to get to than go out in the middle of the ocean to kill a whale. And that was mainly why we ended up saving the whales. Not because people were well-meaning, but because we got a cheaper alternative. If you think about this, we've done this all the way through the world. Back in the 1970s, were we worried about most people starving? Starvation was a real issue. It was not the solution to tell I'm sorry, could you eat a little less and we're going to send it to Africa or to India? The real solution was the Green Revolution. If you look at Los Angeles in the 1950s, where it was terribly polluted, again, the solution was not to tell Los Angelinos, is that what they're called? To tell them that you can't drive, you have to walk instead. That would never have worked. What did work was we invented in 1978 the catalytic converter. It cost a couple $100. You put it on the tailpipe, and then you pretty much don't pollute anymore. That's how you solve problems. So if we focus to spend a lot more in green energy innovation, the trick here is that then it will become more likely that green energy, it'll not work today, it'll not work next year, but eventually will become cheaper than fossil fuels. And then, not just rich, well-meaning Americans, but everyone, the Chinese, the Indians, the Africans, will switch. And that's how we're going to solve global warming. So I'm going to shut up here now, and I'd love to hear your questions. Thank you very much.
We have 3 mics in the audience. One is on a mic stand right here in the middle, and then we have 2 runners on both sides. So if you guys have any questions, you can either come up to this mic, or you can just raise your hand and someone will come to you.
Brilliant. So let's start here.
Thank you. Just got a question. I didn't hear you mention anything when it comes to climate change on Earth. How much does the sun have in regards to affecting the climate change here on Earth?
So I'm a social scientist, so I've worked with a lot of those climate scientists, so I'm just going to give you the standard line. Clearly, the argument is that CO2 by itself is a greenhouse gas, and so that has an impact. It is very likely that other things also have an impact, so there are lots of studies. We have one of the main researchers shown that the influx from the sun, mostly in terms of particles, actually affect the amount of clouds, probably have an impact as well. And I think it's reasonable to say that we don't have enough researchers that look at all the other things that could also be causing climate change. That's a systemic problem, and we should certainly be pointing that out. But it doesn't mean that more CO2 in and of itself will also not mean more temperature rise, and that all other things equal is bad, just simply because we have adjusted all of our societies to our current temperature, or the temperature we've had over the last 100 years when we built most of our infrastructure. And so if it gets much warmer, or even if it got more colder, it would imply a significant extra cost. So we should definitely be investigating these other things. One of the big problems in setting up the UN Climate Panel, and especially the UNFCCC, which they're the ones who did the Paris Agreement and the Kyoto Agreement and so on, they're mostly or almost exclusively focused on CO2 as the only driver of climate. It would be very, very surprising if it was the only driver of climate. We should definitely be pushing for that, but I think it's also worth pointing out that even if you just look at this as partial explanation, the partial impact of CO2 is it's going to get warmer, and that will have an overall net negative effect for the world. Yes?
Thank you for your presentation. Very interesting, and I appreciate that you're here to give it to us. I had a question regarding, are there studies that show that there is positive effects to climate change, and what the value is that to the world, like maybe being able to come to North Dakota in November without skiing home? Is there some positive effects that are not being taken into account in the studies there? Thank you.
Yes, there is. And so one of the reasons why I didn't show you that is because I want to sort of give you the overall argument, which is what Nordhaus does, but all of those climate economists actually exactly point out that there are both positives and negatives to climate change. Overall, there are more negatives than positives, that's why it's a problem, but we're badly informed if we only hear about the negatives, and as I tried to point out, very often badly hear about the negatives as well. So one obvious thing is, if you, this is a recent study in Nature magazine, shows that there are 3 main impacts of climate change. One is temperature rise, you've heard about that a lot. The other one is sea level rise, you've also heard a lot about that. The third one is global greening, and you've heard almost nothing about that. All of those 3 are very clear indicators of climate change. But the first 2 are negative, so you hear a lot about that. The third one is positive, so you hear nothing about it. That's not a good way to inform people. So global greening basically means that CO2 is a fertilizer for plants. You know, if you're a farmer, especially if you're a greenhouse farmer, you know this. Most tomato growers, for instance, will put an extra CO2 in their greenhouses just simply because it makes more plum tomatoes. It's just good business sense. And if we're doing that experiment globally, it's also very likely that you're going to see more global growth. Now, we know this because we've had satellites have estimated that at least from the late 1980s, early 1990s. We actually have researchers that try to estimate how many square feet of leaves are there in the world. I don't quite understand how we know this, but they do. And what has happened over the last since about 2000, where we have very good data, is that we've seen dramatically more leaf area in the world. We've just simply gotten a lot greener. There's a few places that have gotten browner. Most places have gotten much, much greener. So much so that the total average area of all the extra leaves in the world is equivalent to 3 times the contiguous US surface area in the world. We've just got 3 extra USs of green stuff in the world, or 3 extra Australias. For some odd reason, that happens to be the exact same area. How come you don't hear about this? I'm pretty sure if it's gotten browner, everybody would be arguing that's a terrible thing, and it probably would be a terrible thing. But isn't it curious that nobody will mention to you that it's a good thing that there's more green stuff? Again, this does not outweigh that there will be more problems than there will be benefits from climate change, which is, again, why it's a net negative. But we need to hear the whole story. Another good argument, and I think this is very, very useful in the conversation that you hear all the time, as temperatures rise, we're going to see more heat waves. That's just simply basic physics. That's one of the things you've heard a lot about this year. So as temperatures rise, we're going to see more heat waves. If we do nothing about that, that means more people are going to die from heat. That's a terrible loss, and we should absolutely hear about it. Now, I don't know if you know, there's a big study for the US that has actually shown that over the last century, as temperatures rose in the US, fewer and fewer people died from heat. Why? It's not rocket science, right? It's air conditioning. It turns out that air conditioning is a really good way to avoid dying. If you look at the data from Arizona, so from Phoenix, they published, it was a big story in Financial Times last year, about 400 people died from heat in Arizona. And it was a big story about it. More than half of these people were homeless, more than half of them were drug addicts, and the important part is not one person died if they had a functioning air conditioning that ran. Now, some people didn't have air conditioning, some people didn't have a functioning air conditioning, some people couldn't afford to keep their air conditioning running. But if you could afford that, you did not die. And so if you actually care about people surviving heat waves, maybe the first thing is to make sure that they have air conditioning and that they have electricity that's so cheap that they can actually afford to keep running it. That seems like an obvious thing. That's how the US has dramatically reduced the number of people dying from heat. But there's a much bigger point, and that's the answer to your question of the sort of positives we don't hear about. Overall, pretty much in every area of the world, many, many more people die from cold than die from heat. So in the US, depending on estimates, we probably estimate, so in North America, so the US and Canada, about 20,000 people die each year from heat. That's dramatic and terrible, and we should certainly recognize that. But every year, 170,000 people die from cold. Why don't we hear about that? Shouldn't we hear about that? And of course, what is the way to help these people? So the fundamental point, very few people die from actual heat exhaustion or from hypothermia, but most people die because as we get further and further away from the optimal temperature, you get more exhausted, you have more risk of heart disease. So one obvious way that this happens is as temperatures get colder, you get higher blood pressure. What happens is that your body basically restricts blood flow to the skin. They try to keep your core warm, but that ends up increasing your blood pressure, and that gives you much higher risk of dying from cardiac arrest or from a stroke or many other diseases. We know this. There's a big study of the US where you basically see the colder it is, if it's very hot, people have low blood pressure. If it gets colder, they have much, much higher blood pressure. We know this. Doctors will tell you this as well. So what happens is we're seeing many more people dying from cold in the US, yet we talk nothing about this. And how do you save these people? You save them by making sure that they have affordable electricity or gas so that they can actually keep warm in the winter. Mostly the people who die are poor people, they're old, elderly people that can't afford to keep their homes heated. So there's a big study that showed what happened when you went to fracking in the early 2000s in the US. You saw a dramatic reduction in the price of energy, which actually meant that more people, especially poor people, could keep their homes well heated. The researchers estimate that the fracking revolution in the US meant that 12,500 Americans each year did not die because they could keep their homes warmer. Why don't we hear about that? And of course, the implication of climate policy is that we're making energy more costly, which means especially poor people will not be able to keep warm in the same period. Now, globally, there's a new study in The Lancet that actually shows what happened with higher temperatures. We're going to see more heat waves, and hence more people are going to die from heat. But with higher temperatures, you're going to see fewer cold waves, which means more people are not going to die from cold. It turns out that over the last 2 decades, if you just look at the temperature, if you ignore adaptation, because that will probably mean that this didn't happen, but that's not what they estimated, they find that with temperature rising, you're going to see about 116,000 more people die from heat every year. That's a terrible tragedy and something we should emphasize and something we should do something about. But what nobody heard was that each and every year, because of increasing temperatures, we see 283,000 fewer people die from cold every year. We're not well informed if we only hear about the 116,000 more deaths and forget to hear about the 283,000 fewer deaths. So overall, the fact that temperatures rose meant that fewer people died from temperature-related deaths. So about 600,000 people died from heat, but about 4.5 million people died from cold, and overall, about 166,000 fewer people died in the world because of temperature-related deaths. So those are some of the things we also need to hear. It doesn't take away from the fact that overall global warming is a problem, but we should hear those arguments as well. Yes? Sure.
Thank you very much for your presentation. I thought it was very enlightening. We as an industry are pushed very hard currently to reduce carbon by the transition to renewable energy. And the economics that you presented are quite important for us to understand. But the question I have is, where does nuclear energy fall into that mix? And do you have any numbers on the economics? Due to the reliability, I guess, personally, I feel that nuclear has a very important place in our future. So could you address that issue?
Yes. So 2 things about nuclear. First of all, you're absolutely right that nuclear is the only technology that we know right now that can provide baseload capacity and actually deliver virtually CO2 neutral energy. So the true test of whether most people are really, really worried about climate change is whether they're willing to embrace the nuclear question. You know, I find it very confusing that people will say, we're all gonna die. Well, what about nuclear? No, I want something that's unrealistic. That just doesn't sound like somebody who actually believes in a real catastrophe. The problem with nuclear, certainly in the rich world, is that nuclear, or current generation, third generation nuclear, is too costly. For a variety of reasons, we have very, very stringent regulation that's often incredibly costly and has led to nuclear being much more costly than most fossil fuels. So what you have is, and you know, economists would tend to say that maybe that's because nuclear is too safe, but there's just no way you're going to get people to say, let's make nuclear a little less safe. That's not going to happen. So the real outcome here is, the only thing that I can see is fourth generation nuclear, that we basically get small modular nuclear reactors and we get them permitted in the planning stage, so we can get a permit for one and then we'll produce 100,000 of them. They'll be very cheap, they'll be incredibly effective and also safer. Again, I'm a little sort of, that was also what we heard about the third generation. That didn't happen, so let's see if it happens. It's certainly one of the things that we should be investigating, but it's not the only thing. And it simply is one of the ways to show people, if you want to fix this, we need better technology that's cheaper and greener. I just want to give you one other example. I know this is not part of your question, but I'm just going to squeeze it in there anyway. So do you guys know Craig Venter, the guy who cracked the human genome back in 2000? He's a wonderful guy. He has a lot of crazy ideas. One of his crazy ideas is that imagine if we could make algae produce oil. So he has this idea of having genetically modified algae, put them out on the ocean surface, and then basically have them soak up sunlight and CO2 and produce oil. Then we'd harvest it out on the ocean surface, and we'd basically grow our own Saudi Arabias out on the ocean surface. We would have the entire fossil fuel industry as we already have now, but it would now be CO2 neutral. This is a cool idea. Of course, it's not working, otherwise the world would have already changed. It doesn't work in the sense that it's incredibly expensive right now, but we should definitely be spending a few $1 million in him and other people with similar kinds of ideas, because we really just need one or few of those breakthroughs, and that will power the 21st century. It's about getting people the understanding that this is about these ideas. And that also goes to your question, nuclear again. Nuclear is going to be part of the solution for electricity, but unless we can get almost everything electrified, and again, that seems a very, very large ask, at least up till 2050, it's only ever going to be part of the solution because it only provides electricity. The Craig Venter solution could potentially energize the entire global economy. Yes, sorry. We have a question down there somewhere? In the middle?
Yes.
I'm getting too many pointing fingers. I don't know which. Right in the middle, sir. Thank you. Or, ma'am?
Hello?
Yes.
My question is, you know, I really believe in these data-driven decisions. How do we get the data that you presented to be mainstream so that, you know, some of this misinformation is not believed?
It's a great question, and if I knew the answer, I would be doing it. So the short answer is I don't know how we do all of this concertedly. So there's a reason why you hear bad news. If you noticed, since the 1980s, the FBI crime statistic has shown very clearly, disregard the last couple of years, which are somewhat disputed, but since the 1980s, crime statistics in the US has just dropped. It's about halved. So we have much less crime in the US from the late 1980s till today. This is incontrovertible. Yet if you ask most people in Gallup surveys year after year will say there's more and more crime. Why is that? It's because we got CNN, and it's not just CNN, it's all the cable news network, because there's enough crime to put crime on 24/7, and you've still only covered a small part of it. So while you know in the data that there's less and less crime, the feeling for most people is, but I see more and more crime on TV. And we have the same problem with climate. It's just irresistible. It's catnip to a media to show the next city burning or the next flood or whatever. There's nobody that sends out reporters and say, I'm out here reporting and there's no fire here. Right? It just doesn't play. So you will have this situation constantly. The only thing that I know, and this is the answer to your question, I think, is we should get more of that information out there, and we'll get people slightly less badly informed. But we're finding a losing argument in the sense that if you're having a discussion about showing a video clip of fire and showing me talking about, but the satellites show that it's actually going to, the fire wins every time. But that doesn't mean we shouldn't show it. And at least one of the things I find is if you show people that fewer people die from climate-related disasters, and not a little bit, 98% fewer die. If you show them the graphic of fire being dramatically lower in the world today because of satellites from NASA, it makes people a little uneasy. They'll still go back and believe, oh, but the world is on fire and everything is bad, I know. But it will be that, the stone in your shoe that'll itch a little bit and be a little annoying, and that's what we at least can get a little bit more smart, good information and get people to think about this. But I think it's a losing battle to get people to believe right things when the wrong things are just so much sexier. Yes?
Can you make any comments with regard to climate warming and its association with the Earth's tilt?
Sorry, I just didn't catch that.
Yeah, back in July, there's some reports that came out that the Earth is tilted by 31% or something like that, or significantly, and they draw some association with climate warming. Do you have any familiarity with that?
So I haven't heard the thing about the tilting, but surely I believe that we are going to see, the argument is that we saw the hottest July or whatever it is that people have been saying. That seems reasonable. We are going to see more of those kinds of records. And we should just simply say, yes, that is what that's what we would expect from climate science. It's also what we see with the data. It's very likely we're going to see higher temperatures, and we should recognize that that will mean that more people will have more problems with more heat waves. And that absolutely bad impacts, and we should make sure that we adapt for that. So it's especially about making sure that people have access to air conditioning. But we should also, at the same time, that also means that many fewer people will die from cold. We know that from research, and not reporting on it is not a good way to inform people. So I think we need to have both of those conversations, and again, remind people that cold is much, much more dangerous than heat, and cold requires just as much energy. Actually, if anything, it requires more energy because you need to keep warm the entire winter. I think we have time for one more question, or do we have another question, or did all of you guys just agree with everything I said? All right. In that case, you guys have been wonderful. Thank you very much.